Okay, then let's start. Welcome to my talk about the Eclipse TEA project. Let me start with a very short introduction of myself and the company I work for. My name is Markus Duft. I'm working for the company SSI Schaefer IT Solutions in Austria since now a few years, since 2005. I'm a software engineer and working as a software architect for SSI Schaefer. SSI Schaefer itself is a privately held group of companies with more than 9,000 employees worldwide. Most of them actually work in hardware, so in real steel. And only 900 of these 9,000, so 10%, are working in IT, so with software. What we're doing in IT, we're creating a software called WAMAS, that's short for Warehouse Management System, and that's exactly what it is. So we have a few parts in there that deal with keeping track of stuff in warehouses, moving stuff in warehouses, all the way down to controlling the hardware that moves that stuff around. There are like up to 45-meter high stacker cranes that can put pallets into racks and get them out of there. So that's basically the things we're dealing with. Everything we have so far in software right now is Java based. So previously we had C and stuff. But nowadays we're all Java, and at least huge parts of the software are based on Eclipse RCP. So we're not using Eclipse only as a IDE, but also as a platform for our software. So today I want to introduce the Eclipse TEA project. We have a very short agenda. I will tell you what it is all about, a brief history, where we came from, when to use it, when to maybe not use it, and then some demos. According to the homepage, you can read it if you want to read it. TEA is a set of extensions for the Eclipse IDE that allows one to automate tasks. So basically it's all about, I want to do something, and then put that into the IDE so that every developer can execute that. And the important part here is that we want to have it executable by clicking somewhere, as well as being able to execute that in a headless environment, the very same way. So a lot of the infrastructure deals with exactly that. Another part, or the second part of TEA, the first part is the core infrastructure, and the second part of TEA is a collection of tasks that have been written right now 100% by us, but that should be a library of tasks in the future that everybody can contribute to and build that up. So as I said, two parts. One is TEA core, which deals actually only with task execution, but also with visualization, with state handling, with logging, with all kinds of progress tracking, with the integration into the IDE of tasks and task chains. And the second part is the TEA library, which provides the pre-built and the easily usable tasks and task chains. What we have in there is, for instance, build orchestration. I will talk about that a little more. JDT PDE integration, a little bit Maven P2 integration, and LCDSL integration. If you're interested in launch configurations, then I just want to highlight a BOF that will be taking place today at 18:30 in the Wilhelm Kremer Zimmer, where I want to discuss a little bit about launch configurations. So the history of Eclipse TEA, we're coming from a piece of software called WAMAS Power Build, which already indicates a strong focus on build. So it was initially created just with the focus of speeding up our builds. What was the situation where we came from? We had a workspace and we had a lot of model-based stuff in there. So we had generators, we have models and generators. And the generators themselves were actually projects in the workspace. So you have the problem that you cannot integrate that easily. It is possible, but not easily, into the normal Eclipse build. You can work around with AND tasks and artificial dependencies and whatnot just to get that working. So what we needed was some kind of build orchestration that sits on top of everything and knows exactly which project contains what, and then can calculate a correct order for these projects to be built, for generators to be run in between, and have an eye on all of that and coordinate that. The second thing that we wanted to achieve with Vamos Power Build was to replace our AND-based headless build. So we had an AND build, and that consisted of about 10,000 lines of AND XML code, just to configure what needs to be built when, what generator needs to be run when, and so on and so forth. So now we implemented that everything that it can run inside the IDE, and it uses just basically project.build. So what the auto build of Eclipse also uses. And we wanted to have that available headlessly, and that's exactly what we did. So we provided a headless application that can do exactly the same thing as if you would press build in the IDE. As a byproduct of all this, what we did there, we got a quite strong infrastructure for executing arbitrary tasks. So building the workspace was just one of the tasks, but we also had tasks to export documentation, to render some images, to whatever you can imagine, yeah? Export products, export update sites, and do all these kinds of stuff. Last year, we decided that we want to open source that, based mainly on the interests that I got on last year's EclipseCons, where I was presenting about what we do with our IDE, how we extend that, and Vamos Power Build was one of the things I presented. And there was quite strong interest in that, so we decided that we make it open source. Vamos Power Build itself was around 38,000 lines of code before we started, pure lines of code without comments, before we started to split that out into the open source project. And roughly 10,000 of these lines have landed in the open source project right now. So that's actually quite an achievement for 1 year. So TEA has quite a bunch of components right now. We have the core component, which basically provides all the execution stuff for tasks. We have the UI component, which provides integration into the UI, as well as some advanced preference handling and a more advanced headless application, which even allows platform UI.getWorkbench. So this does work in the headless application. So we have everything there. The downside, of course, is we need an X11 display. That's for sure, but there is a headless presentation engine in there that basically mocks away all the UI. This is, I think you will probably know it, the same presentation engine as used in the unit tests for the workbench. So there is one provided in the unit tests. Then we have the TEA Live View component, which provides a view that allows monitoring of task execution, progress reporting, status reporting, even down to compile errors. Then we have the ease integration. Ease, developers are sitting here, where we can provide tasks as scripts. So we can program in Java code that we want to execute a script as a task, and we will run that script in the workspace. And also the other way around, we can program task chains in script languages, so in JavaScript, Python, whatever. And then the TEA Build library, which provides build orchestration tasks, JDT PDE integration tasks, Maven integration tasks. So this is already the library part where no more infrastructure is added, but rather only reusable parts that you can actually just consume. And on top of that, this is split out a little bit. That's the TEA Build library LCDSL integration, which basically allows us to on the fly build and generate launch configurations from a textual representation, and also execute that during builds, or even have that as separate nodes in the build graph and execute them and manage the dependencies between projects and launch configurations and stuff. So when would you want to use TEA, the TEA core infrastructure? Actually, whenever you have a task that should be automated for developers. So if you have a simple task like write an HTML file, everybody needs that changelog, I don't know, yeah, you want to basically do git log with certain parameters. Maybe that's a task that people very often do in your scenario. You could automate that with a simple task where you just program that in Java. And that task would then be available both in the IDE as well as headlessly. So we're actually doing that exactly with the changelog example. We have a task where you can just click that in the IDE and you get the current changelog, as well as exporting the changelog during nightly builds. That's basically it. Another good situation in which to use T is when tasks get huge or numerous. So we have around 300 to 500 tasks in our current IDE that do various things, and most of them are rather complex. So there are no like 10 liners, it's more like 500 liners in that area. Otherwise, you could easily do it just with scripts. That would not be a problem. And tasks can be used on empty workspaces. That's something I heard is also possible with scripts, but that would be one of the things that you can automate workspace setup with these kind of things. Of course, nowadays, this is all stuff that we did already 7 years ago. Nowadays, you would use for whatever.
Do you have some predefined set of tasks, or
we have predefined tasks, and there will be even more. That's in the T library, yes. There are, but not for workspace setup right now. These are basically still, let's say, a little bit company specific that we have, but we're working on that. So there is something more we plan, and possibly we will integrate and release that with T. Yeah, but in reality, a good mix between T and E's gives pretty good results, because on the one hand, you can program tasks in your IDE, but on the other hand, that also means you cannot change it, and you need to take care of updates or releases, versioning, whatever of that tasks.
I'm sorry, what is T and E's? Is that like a framework for UI?
What's E's? Ease is the Eclipse Advanced Scripting environment. So that's you can ask Christian afterwards in more details, but basically it's a scripting environment for the IDE, so you can script that IDE. So you can write JavaScript, Python, whatever language you like, and you have basically access to every package that is exported and that runs in the IDE. So not in the workspace, but in the IDE, which gives pretty good possibilities, of course. So providing a set of functionality with eScripts is a good idea if you want, for instance, branch-specific stuff. You want to treat master branch differently than a release branch or whatever. So you have the actual functionality that is executed in a chain or set of tasks. Certain functionality you can put in scripts, and then you will have specific behavior depending on which branch you're on. So then we have the T library. The T library is exactly the place where such additional tasks would go to. That's stuff that in the first place we created up front, because we have already like 300 to 500 of them. So we would contribute everything that's not company specific there. Yeah? But also I would really like to encourage, if somebody is using T, then contribute to the library, of course. That's exactly the plan. What we have in there right now is a build orchestration. So we have, I will demo that later, a complete set of build orchestration where you can basically compile your workspace. That's it, but also you can put in nodes in this build orchestration graph that it uses to calculate order of build, where you can, for instance, run a generator. Based on some input criteria, you can decide when it is time to run the generator. You can do dependency wiring between projects and all these kinds of things. And it's very, very easily extensible. And why is this better than, for instance, putting an AND task build step in the Eclipse project builder configuration? Yeah, well, you can provide something that is not related to a single project. So for instance, you might have multiple model projects and multiple target projects where you want to generate code into. So it would be rather hard to configure all of this in a way so that it will work out in the end. This is not a problem with T, because you can simply wire dependencies from and to the generator more or less freeform. I will show that later. Yeah, we provide additional tasks, mostly in the area of build. So building projects, building update sites, generating feature XMLs, and exporting P2 update sites from that, generating products, exporting products, building products, even with launchers and stuff like that. This is all in the T build library mostly already there. Some things are still missing or in the progress of being added there. And we have the integration with the LCDSL project. So what are the drawbacks of the approach that we chose? If you build your build on the basis of T, you will have to have an Eclipse installed on every server that should run the build. So that's kind of a drawback, because you need to think about how to update these Eclipse installations. This is not part of T itself, but it is possible, like we do it. We're using SDC that's Security Delivery Center, to deploy our IDEs, and they provide some update mechanisms. So we've written a T task which automatically updates our IDEs in the nightly build environments. So it's possible, this is all doable, it's just not there yet. And as I said before, you require a display to be set whenever you have a task that accesses the UI in some way. And it's actually sad but true, it's extremely fast the case that you somehow access the UI, and even if it's indirect. Yeah? As soon as you're dealing with launch configurations, with building projects and stuff like that, that's everything in that area is built into Eclipse UI related or UI specific plugins. Okay, so let me show you a little bit of what it's about. So regarding tasking, so I'm always talking about tasks and task chains. So let's assume I have a very simple task. I just want to output hello demo and then sleep a while. I can use @named, for instance, to give that name that task a human readable name, which makes the presentation a little bit nicer, but that's just optional. And I need to have a single method with an @execute annotation, so we're using E4 dependency injection heavily in there. So everything is built upon that. And then, as a second part, I have a task chain. A task chain can basically wire up an arbitrary number of tasks that have to be executed for a chain. And it's strictly ordered, so it will execute one task after another in the order that I have added it to the task chain. There are a few annotations and an interface here. The task chain interface actually is completely empty. It's a marker interface just for usage of declarative services. Everything in T is pretty dynamic, so we're using declarative services wherever possible. So you can pretty much swap out and add task chains dynamically to your IDE if you want to deal with a bundle activation and stuff like that. Then there is a task chain ID annotation on here, which basically only adds a description, again a human readable string to the task chain, and an alias which I can use to headlessly reference that task chain. So if I start the headless application and tell it what to run, I have the option of either giving it the fully qualified name of the task chain class or an alias if I have given it some alias. And a task chain menu entry, which means I want to have this task chain displayed in the T menu. I will show that in a second. Now if I launch an Eclipse with this plugin added, I will see that I have here an entry demo1 in the submenu demos. That's basically the submenu demos is defined here, and demo1 is the description of the task chain. That's too early. So now if I run demo1, I will see that it prints out hello demo and then waits for 2 seconds. I will do that again to show the live view. You can see some progress reporting, which is cut off here. Okay. So progress reporting, status reporting of all the tasks executed, and if there would be an error, I would even get error markers down to the actual error that happened. Now, there is another feature that I've shown you actually more or less by accident right now. That's progress estimation. So what we have in here is that if a task takes a certain time, it will do something very similar to the Jenkins ETA stuff. So it will tell you how long, or it will measure how long the task took last time and will give you an ETA and the progress reporting based on that. You can of course overwrite it. So as you can see, it will now be wrong because it's now taking triple the time. But now if I run it again, it will already adapt that progress estimation. You can always overwrite that. So if you have a very strict amount of items that you want to process and you know it's always 10 or whatever, you can do that in a completely manual fashion too. You can just get a task progress tracker injected and then use it like progress monitor. Yeah? Basically, that's what it is. Okay. Questions for the first demo? Then I will just very shortly also show. This is, by the way, LCDSL, so this is what the BOF today in the evening will be about. I can define launch configurations in this DSL, and here you can see that I have I'm using the headless tasking engine application in this case, and give it the demo1 chain alias that I defined before. So please execute me this, and I can run this without clearing the workspace. And it will execute the very same thing. It even has the estimation from the previous runs because I'm using the same workspace in this case. And it will do exactly the same thing, so it will execute the same code. And that's a paradigm for Eclipse TEA that's found everywhere. So every task should, as far as possible, be executable from the IDE and headlessly. Of course, in some areas that's not possible. We also have tasks in our IDE that will open up a dialog and prompt you for some input. We have that. We even have support in T for that. So there is a TaskChain UI init method, which allows you to specifically open a UI in a UI thread and put some things into the Eclipse dependency injection context so that it can be consumed by the task later. Okay, on to demo 2. So what I told you before is we have this build graph and build orchestration stuff and how to add generators to this build graph. If I have a look at my demo Eclipse, I have a project here, my test, and it has a my class, and it wants to access example generated const, a class that should actually be there. Now if I try to build that project, it will simply fail because the generated code is not there. Now how would I write or integrate the generator into the build stuff? First of all, what I need is a build element. The build element is basically the generator. So there is not much more in there than just the code to generate a file into a certain location. It has a project where to put that into, and that's it. So that's the code to generate and refresh. Then I have a build element factory. The build element factory is called by the build graph calculation for every single project. So it wants you to create build elements, possibly create build elements for every project in the workspace. So you can react on every project. But you don't necessarily need to create build elements. For instance, what we sometimes do is we have a generator, and the first time we encounter a project that will need that generator to be able to compile, we will create a build element that runs that generator. But if we encounter later on projects that also require the same generator, we just simply ignore that and know that there is already a generator. In this simple case, we have a configuration where we can configure a project name. So for instance, we have this my project, my test, and once the name of the project is the configured name, we will create a generator that generates this exactly const class into that project. That's also pretty straightforward. This configuration is a concept of T on how to provide additional configuration for the whole system. In this case, it's just a POJO which implements again a marker interface so that it's available for declarative services, and some metadata on that and on each field in this class string, which provides some additional human readable descriptions for that. And this configuration it can be set in via a property file, so you can use in a property file exactly these keys to set the values, but also it will provide you with a configuration section in the Eclipse preferences. So you can very easily define just a configuration pojo, and it will automatically generate the configuration page for you. So in that case, the demo generator is configured to some default, because that's actually the default that's here in this assignment. So my assumption now would be that the generator is not run when I run this clean and build all projects. And that's exactly what will happen. It will tell me, no, I cannot compile this because it's just not working. Now, if I change this configuration and put here my test, for instance, and I rerun this build, then it should automatically generate this const file, hello EclipseCon. My class is happy, it will compile, and I can run a Java application which will then output hello EclipseCon. So, but we have talked only about 2 of these now, 3 of these 5 classes. What is there else? So there is a build visitor. Build visitor is the one that is called whenever a set of build elements should be compiled. So this algorithm in the background, it identifies build elements that can be run in parallel. Basically, it does this. Eclipse cannot compile projects in parallel, but other build elements might be able to run in parallel. So this visit method is called for each build element, set of build elements that can be run together. And in this case, the demo2 build visitor, it just wants to handle demo2 build elements, because that's the generator it wants to run in that case. So it simply calls the generate method on each of these build elements once the algorithm in the background tries to run all these build elements. And as a last thing is, how does it know? How does this algorithm know when to call which build element and what can be run in parallel and what not? This is the task of dependency wire factories, which basically introduce dependency wires between the nodes in the graph. So even for PDE, for plugin projects, we have a dependency wire factory, which basically very simply says, give me your require projects, give me your imported packages and the resolved bundles that this results to, and add a dependency wire to each of them. And the result is a graph that can be visited by the build visitor. In this simple case, we're basically iterating over all elements that have been created by all the element factories. And then if it's a demo2 build element, we know that the project that we want to generate into has a dependency on the generator. So the generator needs to be run before the project can be compiled. In that case, we're just saying, dear project, I know that you have a dependency on me. So I'm creating a dependency wire which wires up these 2 elements. You can also see that in the build output, you can see here that it will generate the file before compiling the project. Any questions to that? In that case, again, I'll just very shortly show that also the compiling of things is basically, I'm starting an Eclipse with this application, and we will do exactly the same thing, generate the file, compile the project. So there is no extra effort in making this available headlessly, 0. So last example is a little bit more about ease and scripting. So what if I want to execute something that I know I want to execute something, but I don't know how it exactly will look like. So I don't want to write that in Java code, but rather have a script that will do whatever I want to do. In that case, I can add to the task chain script tasks. with a named script. And this name, that's ease specific, how it's calculated, will be looked up in ease and then run as a script. I'll show that quickly. There is the ease script explorer, and I have a script called script task, so I can execute that using this task chain. So I have a task chain that wants to run a script. Now this is also integrated into the menu because I have the annotations on the task chain. If I run that, it will output exactly what is here. This is some scripted task. It will tell me this was an ease task, executing this script, and that's it. Basically, that's all that's required. Now, it might also be a good thing to have the possibility to, for instance, extend task chains. Let's assume I have this clean and build all projects. And now I really need a specialized clean and build all projects because I need to do 2 or 3 additional tasks before or afterwards or however. Then I can also do this by writing a script which allows me to create a task chain based off another task chain, which is the one that we have implemented before, or which we deliver with the T library, and add simply another task. In this case, this my task is something that Python can interpret. So I have defined the method my task, and whatever code I put in here, that's the scripted task. Basically, I can put Python code directly in there, into that string. And then I just tell it to please run the task chain, and that should happen. What's also noteworthy is that we introduced the keyword T true. If I have that, it will also put that into the menu. So this is actually the menu entry for the scripted task chain. I can demo that. If I remove it, it will just disappear. So that's also very dynamic. So you can switch branches and have a completely different set of actions that is possible for that branch, or maybe the same set with a different functionality beneath it. But I want to have that, so I can execute it from here. And once I click that, you will see that it will again run this generate and compile as we had before, because I'm extending the task chain that was already there. But then afterwards, it will run the my task method, which is the task that is scripted in here. And also, all of this has good exception handling. So if I have a look at that and run again this example, I will see that in the progress reporting, I will see errors. The errors will bubble up through the Python interpreter and will be handled by T accordingly. Also, I can here open the status until I'm really at the real exception level. Good. That's basically it from my side. Are there any questions?
How do you manage
Yep.
How do you manage your headless builds, build results of building of hundreds of projects with Eclipse GDT automated build and so on? I mean, isn't kind of time to rebuild what you already have, or do you build in the same directories where it expects the output, or how it's done by you?
Actually, we're always building from scratch. So we're resetting everything in the repository, building from scratch. And one of the things that was a key focus was performance, of course, when we implemented all of this. And right now on the Linux box, we're compiling like between 5 and 6 million lines of code, I believe, 850 bundles in 3 minutes.
No, I mean, then your developers most likely open an IDE after that.
No.
No.
We'd never open an IDE in the headless build.
Okay, no, I mean, they have to code sooner or later. They open an IDE where all these projects are.
Yeah, the developers.
They are pre-compiled, most likely?
No.
Ah, okay.
No, never. So what we usually do is when you create a new workspace, so when you download Eclipse, install that, you will be already, that's company specific, be presented with a wizard that allows you to clone a repository and then check out all the projects into the workspace, or import all the projects into the workspace. Then you basically click the clean and build all projects, and it will run all generators and everything and be done on Linux 3 minutes 30 to 3 minutes 50. and on Windows 8 minutes or something like that.
It's outside of the IDE? Or inside?
No, that's inside of the IDE.
But auto build is then off?
Auto build will be enabled automatically after the clean build of T has run. So of course we're disabling the auto build during buildings, but we also can communicate that state of the projects to the auto build. So Eclipse will recognize after T has finished that everything is okay. That's rather new.
And your build output of the headless build points to the same bin directives, let's say, which the Eclipse builder, internal builder will use maybe?
Everything would be the same, and you cannot run a headless build on a workspace that is currently used, because that's Eclipse limitation. So if you have an IDE open on a workspace, you cannot open a second IDE. Since T is building on that foundation, it also cannot run on the same workspace. So you cannot start a headless build on a workspace that you have currently open. And it would not make too much sense because you have actually the button in the IDE. So if you have the IDE open anyway, just click that button and it will do exactly the same thing. So for us, it's also possible to basically trigger a complete nightly build online in your IDE, because that's just a set of tasks. It's a task chain, yeah? It's called TaskChain nightly from scratch, and it will actually execute the exact same thing as all our nightly build machines do. Which has a slight benefit because you don't need any duplicate configuration. We have no extra configuration for nightly builds, zero. That's everything. You know, Eclipse knows everything already about your workspace, about your projects, about how to compile it, how to do whatever kinds of things. So we're just reusing that. Okay, more questions? Then be sure to visit the Eclipse TEA homepage and don't forget to rate the session.